Stat, calculators, normal. Find the area of the shaded region for the graph to the right, which depicts IQ scores of adults. Those scores are normally distributed with a mean of 100 and a standard deviation of 15. I could convert it to a z-score, or I can just put it in like this. Notice it's between two numbers, so I'm going to put this as between. And my lower limit is 106. My upper limit is 128. And I hit compute, 4 decimal places, copying it and pasting it in. Find the indicated IQ score. The graph to the right depicts IQ scores of adults, and those scores are normally distributed. We have the same mean and standard deviation, and we want to find X. And we know that our probability, which is the same as the area under this curve, which is 0.8, we want standard. X is going to be greater than some value, and our probability is 0.8. And we hit compute, and this is our IQ score, and we round it to 1 decimal place. That'll be 87.4. Engineers want to design seats in a commercial aircraft so they are wide enough to fit 90% of all males. Accommodating 100% of males would require very wide seats that would be much too expensive. Men have hip breadths that are normally distributed with a mean of 14.7 and a standard deviation of 0.9. Find the P of 90. That is, we want to find the hip breadth for men that separate the smallest 90% from the largest 10%, 0.9. And I get this value, and that's to 1 decimal place would be 15.9. Or I can say greater than 0.1. When I hit compute, I get the same value for X. To check, suppose that the sitting back to knee length for a group of adults has a normal distribution with a mean of 24.2 and a standard deviation of 1.1. These data are often used in the design of different seats, including aircraft seats, train seats, theater seats, and classroom seats. Instead of using 0.05 for identifying significant values, we're going to use the criteria that a value X is significantly high if the probability of that value or greater is less than or equal to 0.01 is back to knee lengths greater than, I want it to be less than 26.8. And then here, the lower 1%, and I get to 1 decimal place, 21.6. It has to be bigger than 21.6 and smaller than 26.8. We really want the area. Our largest value was 26.8. We want this area that is in yellow. In red is the part that I do not want. This probability here is 0.01, and this probability here is 0.01, which is the same area on both sides. Now, using this criteria, is a back to knee length of 26.4 inches significantly high? 26.4, it's around here. Is it in the critical region or is it in the region that we're looking for? This is not significantly high because it is inside the range of values that are not considered significant. Out here, This is significant, and this is significant. The red is significant. The yellow is not significant. It falls inside, and we did. I pulled up another of the same question because I wanted to show you another way you could do this. It'll have different numbers. I'm going to go to Stat Calculators Normal because this has a normal distribution. We have a mean of 24.8 and a standard deviation of 1.2. These data are often used in the design of different seats, including aircraft seats, train seats, theater seats, and classroom seats. Instead of using 0.05 for identifying significant values, use the criteria that is a value X is significantly high if P of X or greater is less than or equal to 0.01, and a value is significantly low if P of X or less is less than or equal to 0.01. Similar to the last question, but I wanted to show you another way. I want this area to be 0.01, and I want this area to be 0.01. But what I want to know is this part in the middle, and I need to find the endpoint. If I have 0.01 and I add 0.01, I get 0.02. 0.02 is really the part I don't want. I would call this the red area. But this graph is symmetric. What I want is 1 minus 0.02, which is equal to 0.98. I want this area, and I want to know what numbers bound that area. I can use between, and here it's going to be between. I know the probability. I don't know what the numbers are. So I'm going to put 0.98. Since it's symmetric, it's going to always take the 0.01 off of each side. I hit compute, and now I have the back to knee lengths are greater than the smallest value. To one decimal place, it's 22 inches, and less than 27.6. That's a little bit easier than doing each one of them separately. And now a back to knee length of 27 inches. 27 inches is between 22 and 27.6, is not significantly high because it is inside the range of values that are not considered significant. Anything in here is not significant. These ends are the significant part. Thanks a lot. Have a good one.